Okay. Okay, it's recording now.
Okay. And what I
Uh,
will do is ask you to please share your screen.
hmm. Oh, okay,
Okay.
so,
So
all right,
you
so,
are, I would like you to click on the orange colored box in the upper left corner. Click
which one?
orange box, orange colored
This
box.
one?
Yes, click that one.
Okay.
And now go all the way down on the left side. Networking
Um,
VPC. That's what
uh-huh.
here
Uh-huh.
you have the two VPCs there, right? Two VPCs.
Right.
You click on the two number and
It's-
you want to delete one of your VPCs because the one that you are, so click on the number two, please.
See, it's not responding. I'm clicking on it.
Okay, okay. I would like you to try a different browser,
Okay,
like Safari, like Chrome, for example.
oh, I don't have Chrome installed here.
Okay.
I have to install Chrome.
So yeah.
Okay, you know what? It is like this might be difficult. Let's just do this one on one so that
Okay,
we
that's totally fine. One-on-one is
okay.
okay.
Yeah, I think that might be
And
better.
meanwhile, please install Chrome. That makes you like it.
Yeah. Oh, okay, I'll go ahead and do that.
Thank you.
All right, thank you. I'm
So
stop sharing
I
now.
will double check that we are still recording. Yes, we are. And
Yes,
I'll
sir.
share my screen now.
Okay.
And so here we go. I am now sharing my screen. Please cross check whether I'm still recording.
You're still recording.
Okay.
Okay, thank you.
Yeah. So here now I am going to do is continue along. After the break, what we just did is that we first of all created a blank VPC called Cloud Genius. We created two subnets. These subnets are 10.0.0.0/24 and 10.0.1.0.24. Those two, right here, 10.0.0.0.24, 10.0.1.0.24. That's the only difference is here and here.
I'm there. Okay.
Apart from that, we have these two subnets created. We created a gateway, and now we are going to connect them. Like connect the PC subnet with the gateway to the internet to the world outside. And we will make sure to remember to not connect the private subnet to the internet outside because we don't want to. That is
Right.
also important. To not connecting is also important. So remember that.
Okay.
We're not connecting that to the private should not go to the internet. PC should. How do you do that? Is through the route table. So go to the route table section in here, and here you will find that they have given us one route table already. This is the one. I'm going to call it do not use. Anything that they want to give me by default, I don't want to touch it because I don't exactly know what they may have done. So I want to really understand, and that is why I'm going to create two different route tables right now. Route tables are basically how you would allow traffic to flow from one location to the other.
Together.
It is the routing table. That's what we are creating, a table. Literally, it's a table. And in that table, we are going to begin creating. So click create a route table in the Cloud Genius VPC. And here, I'm going to name it border check route table and say create. That's it. That's all it takes. And then another route table. Click this one called private route table and click and create. So we have two tables created by ourselves, and we are going to use those two, the BC one and the private one. The other one that was given to us already, we are not touching it. Do not use. So we're not touching it at all. Having said, excuse me, let us understand in the BC table here, the BC route table, I want to understand the summary. The route table has an ID. It is not associated with any subnet as such. No association, 0 subnets. It is not the main route table, and the VPC name is Cloud Genius, which is good. Now let us go deeper. Routes. Currently, the route table for BC says that I can route to any destination. I can route my traffic to any destination as long as it is in this subnet 10.0.0.0/16. I can go anywhere I want in the entire VPC. This is 16 is the whole VPC. 24 is the one of the subnets, like /24. 16/16 is the entire virtual private cloud, and I can connect to any of the machines within my entire VPC. But I want to really go to the world outside, like public internet. I want to go to CNN.com, go to Google.com, and that is not inside my VPC. It is outside. So I need to have the route expanded. So my route, I need to edit and click the edit button and say that I want to add another route. So I'm adding one more entry to the routing table. Add another route, click. I want to add another route. Primarily, what I want to be able to do is and in the, hold on, the VPC filter, Cloud Genius, BC route, edit, add another route. And you know what? Like Tosin, I am running into the same problem. I'm clicking this button and nothing happens. Craziness.
So you're trying to add a route to the public subnet? You only add to the public subnet, right?
So I have 2 subnets and I have 2 route tables created. One is already given to me, but I created 2 route tables, and I'm going to edit my route table by clicking the edit button and then say add another route. When I say the add another route button, this browser doesn't seem to like it. It doesn't seem to do anything. And this is sometimes craziness of browsers, of service providers, and I don't know what. So the solution to these problems is to open a different browser, like Firefox, for example, and go to the same location. Sometimes it works. You know, there is no root cause I can do for Amazon website to not respond to my clicks. I can do nothing literally because it doesn't respond. So I don't know what to do. Maybe I'll try adjusting the font size. Maybe I'll set the zoom settings differently. No, maybe I refresh the page a couple of times and try it one more time, but sometimes it just does not want to listen. The best workaround that I have found is to make sure that I use a different browser, and it might work. Add another route, no response. And I'm tired of this browser, so I'm going to change it to this browser. Here I'll go to console, same thing, log in the same way. And then I'm going to type the token. So my token is available in 1Password. I will generate a token and type it, copy from here, token, paste it here, go. And I am connected to Firefox. Same location, same everything, VPC, and then my filter to subnets, filter by Cloud Genius VPC, go to the subnet, go to the route tables, examine the BC route table. And in the route section, I want to edit my route, edit, and then I want to add another route, click. And it does not want to respond. How idiotic that is. Okay, it doesn't respond. Edit, click, save. Now go back to routes, edit, add another route. Okay. I see what's going on. So I think it was my mistake. I forgot one simple step, That is why it is not asking me to let me click the button. The mistake is that I have not associated the gateway with this VPC. I thought I created a gateway before the break, but apparently the gateway did not get created. I recall, maybe I'll go look at the recording, but I think I created a gateway, but apparently there is no gateway. So it means I need to create one. And so I need to type it GW. And I think I did, but maybe it did not complete successfully. So I'm going to create a gateway one more time and wait for it to happen. It did not show me any gateway created. And so, yeah, there are 2 gateways created. Okay, now it shows me both of them called GW. I'm going to delete one of them. I don't need 2 gateways. Only one is good enough. But the important thing that is missing is to make sure that I associate this GW gateway with the VPC. So I need to select that and attach it to the CloudGenius VPC like this. Say, yes, attach. And that is literally connecting a cable from Comcast to my router. I just did that. Now again, filtering back, and I see that my gateways, there is one. It is attached to the VPC called CloudGenius, like this. And now I can go back to my routing table. I know these screens can be a little bit convoluted to comprehend, so I will go slow and clarify multiple times until you really get it. It can be driving people nuts, and I understand. But watch this carefully again. So there is this BC subnet, sorry, BC route table and a private route table. So I'm selecting the BC route table first. Looking at the routes, I see the route is 10.0.0.0.16, which means I can go anywhere in the VPC, not outside. So I want to expand the route. I'm going to edit it and add another route. And now it lets me. Now I'm going to say, I want to go anywhere on the internet. And the target should be the gateway, please. See that target? I select like the gateway I want. And then I save the route. So in my table, now I have 2 routes. One going to anywhere on the internet, one going to anywhere within the VPC through a local target, all internal to the VPC. And the second one goes anywhere on the internet, 0000. And this goes through the gateway, this one. This one is the gateway I created here. You can see 6117, that number is this gateway 6117, which is attached to the VPC CloudGenius. That's what you're looking at. So back in our Chrome browser, you see the same thing. Refresh, and you will see that this CloudGenius VPC has 1 gateway, GW, 2 subnets called BC and private, 2 route tables called BC and private. There is a third one that I don't want to use, but ignore that. But focus on BC. I have expanded the routes and let the routing happen to anywhere on the internet referred to by 0000/0 using the gateway, and that route is active. Want you to note that. That is how you want to connect the cable, literally connect the cables like you saw here. Is this subnet I have connected through the gateway, which lets me connect to anywhere on the internet. So that connection is now connected like this. You will also want to make sure that this BC subnet, BC route table is associated with only the BC subnet. So check, edit, and see the association flags here. You want to associate the BC route table with the BC subnet and not the other subnet. So you want to make sure that you actually remember that BC should map to BC, BC route table mapping to BC subnet, check and save. And do the same thing for the private routing table. Private routing table, subnet associations, edit, associate this private routing table with the private subnet and save. And when you do that, you know that the private routing table is associated with the private subnet, and the BC routing table is associated with the BC routing subnet. So that association, you need to make sure the route table association with the appropriate subnet is very important. So you will see that BC mapping to explicitly associated with one subnet, which is the BC subnet. Similarly, the private routing table associated with only one subnet, that happens to be the private subnet. And that is what I just did on the subnet association screens for this and this. Two routing tables, two subnets, one-on-one mapping. You saw that. We'll also see in the BC routing table, the routes are 10.0.0.0.16, go anywhere you feel like on the VPC, fine, local connection. They're all already connected internally. But for things on the internet, you need a gateway. So you got the gateway from here, you connected, attached to the VPC, then you mapped it in the route table as a route. And on the private route table, you will see that the routes are limited to only within the VPC, 10.0.0.0.16. And there is no route to the internet. We don't want it directly connected. Let me clarify that. So what I'm saying is, what we have up until now, we have this VPC. It has an address space of 10.0.0.0/16. We have this subnet, address space 10.0.0.0/24, and this subnet 10.0.1.0/24. And this we call BC, this we call private. So we have two routing tables also. One for the BC subnet, there is an association called routing table. In this, we say go anywhere on the VPC 10.0.0.0/16. Yeah, go anywhere local connection. So there's a local connection available. So anything is connected to anything else within the VPC, no problem. You can just route the traffic. So that is a local connection, no problem. And same is available to the other subnet. You have another route table for this subnet. And so it allows you local connection to anything in the VPC, no problem. But that's not the point. The point is, I want to explicitly make sure that anything on these lines should connect through a gateway to the public internet outside, like CNN or Google or whatever. But this GW that we created is how it should be wired. And so that it can go to anywhere on the internet. Whereas I don't want these guys, machines that are created here in the private subnet, to connect directly to the gateway and through go to the internet at all. No, sorry, I don't want it. I want to keep it safe. I want to keep it private. And that is the scenario that I want to build, and I just built. However, I still want them to connect to the internet, not directly though, but indirectly. And this is similar to, very, very similar to you getting a laptop, or rather you getting a laptop in your home, and you can directly connect it to the Comcast cable modem. That is a possibility, and it will work. But your laptop gets a public IP. And that is not what you really want. What you want is, you get Comcast, you want to connect to a router, and then have your laptop connect through the router, through the gateway. So Comcast is the gateway. A router is a separate device that you buy. You have to buy it from Best Buy or something, eBay, Amazon. So you buy it separately, and that device protects you. It gives you network address translation, gives you firewall, gives you 100 other things. That is what you want.
So my router is something like a VPC, you mean?
Yeah, home is like a VPC.
Home is like a VPC. My router is a gateway.
Your router is a NAT device.
NAT device.
Comcast is a
Okay.
gateway. Your home
Okay.
is VPC. Your farmhouse is a VPC, right? So your home itself is a virtual, conceptually, it's not a cloud, but it's everything else that we discussed. From a networking standpoint, it is very similar. You have to have a gateway, which gives you access to the world outside, like CNN, but you want to protect your laptop so you don't connect it directly to the gateway. Otherwise, you will get a public IP, which is not what you want. You want to get a private IP. And you want to hide it and let somebody masquerade it. Masquerade. That somebody masquerading you is a NAT device, which is a router. And that is what you buy. And that is exactly what we will do here. We will buy a router right now and connect it right there. We'll buy a router and place it right here. And then we will connect these machines like this. And the router will connect through the gateway and then go outside. So bad guys, these bad guys that you have on the internet, they can go here, no problem. Go here, no problem. This router will prevent them from accessing these things because it is acting as a NAT. They cannot reach inside the private subnet.
Oh, you said bad guys can go into a VPC?
Yeah, bad guys can go to the gateway. They can reach the NAT and the traffic will get rejected here. Yeah, they will reach the gateway, no problem. They will.
Or not the yeah. They can reach into the VPC, into the machine from the VPC, in the public subnet.
In this scenario, they will, because you have your border check subnet and a NAT device sitting, they will reach the NAT, no problem. The NAT will reject them, and that's the security. So your gateway is open to the world. Your NAT device is basically rejecting traffic, right? So you have this internal subnet, which is the border check subnet. You have your gateway device, which is literally the Comcast cable modem. Bad guys can reach here, no problem at all. And this is directly connected to the router, which you have here on the border check subnet. And so they can reach the router as well. They will reach all the way to this point, and this guy will reject them. That's the scenario. If you wire it like this, that is what will happen. Your machines are safe here in the private subnet. Then we'll build this argument in greater level of depth, as you will see in real live examples. So I want to get a router. I will go shopping, literally go shopping. So before I go shopping and getting a router, because that's what I really want to connect, is place the router here on the BC subnet, and then come back to the routing table and say, go like this. Please go like this. Don't go like this. You can put an entry in the gateway in the routing table and say go directly, and that will be bad. You're exposing your machines. You don't want to. You want to prevent them from being accessed from outside. You want to protect these machines. And so that is exactly what you will do, is don't make the mistake of hooking up directly to the gateway. No, no, no. Buy a router and put it right here. So I will now go shopping, get the router in place, and then hook up this connection like this. And I can do that by manipulating my routing table. Okay to go to the gateway. Routing table for private. Don't go to the gateway. No, go through the router.
But no problem to go to the, but no, even with the router, no problem to go to the public subnet, right?
Question again, please.
Oh, even with the router, no problem to go to the public subnet.
So we have a subnet called BC. Is that what you mean by public subnet?
Yeah, yeah.
So machines can connect to the VPC, yes, no problem.
Right, right. But from outside, even with the router, bad guys can still get into public subnet, even with the router.
Correct.
That's right?
Correct. Because you have connected like that. You have connected it directly to the gateway. The router is not in the picture.
I see.
From a BC subnet, the connection happens to be go directly. For these guys on the private subnet, you go through the router.
I see. So the actual security for the VPC is in the private domain, private subnet.
Correct.
The machine from the private subnet.
Mm-hmm.
Okay.
Yes. In this design, yes.
Okay.
That's exactly true. We can modify our design, but in this design, that is exactly the case. Bad guys can come here. Bad guys can come on this side, but not here. Not here. They cannot come here. They will get rejected right in this spot. Okay. Cool. So we'll move forward now. I want to be able to go back to this route table for private and edit the route. And here I want to add another route. And I want to say that go to anywhere on the internet, but please, please, please don't use the gateway. No, not the gateway. I want to put the NAT device here, or my router that I will buy. Now, router that I will buy, I want to show up here and put that entry right in that section here. And then I will save it. If I save it like this, it doesn't mean, if I save it with a GW, that's a bad idea, because I am connecting my private machines directly to the gateway, which is not what I want. So I'll cancel. I will wait for me to go shopping, buy a router, come back here, private route table, edit, add another route, 0000/0, and my router here. And then I will save. If I save it like this, it says target not found because I don't have a router. So I need to go get a router, put that in my BC subnet, and then come here again. Okay, so I'll do that. Let's go shopping. So we'll go to Amazon, go to EC2, and here, launch an instance. What do I want to launch? Not this Ubuntu, because it is not a router. I can create a router out of this Ubuntu, but that's too much work. It's not really too much work. It's just a few scripts. So you can convert this Ubuntu box into a router if you like, and we'll do that later. But for right now, let us go shopping. So we'll look for the marketplace. And here, let us search for NAT. And it's expensive. So I don't want to use that Cisco NAT. It's very expensive. So I'll go cheaper. I'll say, give me Amazon NAT, which is Amazon Linux, which is basically Red Hat Linux. So that I have, okay, the keyword should be NAT 2016 or 2015. That should pop up. A good NAT for cheap price. No. Okay, so NAT 2015. Amazon NAT 2015. Where is that? Okay, it's not popping up like this. So I will do a Google search. Amazon NAT device. Come on, give me NAT instances. So there we have NAT instances. NAT instance, setting up the NAT instance. And so there are a couple of updates to Amazon that has happened, which is why it is a little bit difficult to find a NAT instance. But I want to go through the principles that are common to every cloud. Amazon has come up with this idea of a NAT gateway that you will see a reference to somewhere here in Amazon. There is a new idea started this year called AWS NAT gateway. That is what they are trying to sell people. So that is the reason why this NAT shopping is a little bit difficult. So difficult to find. It's not that big a deal, but they want to sell you this thing called NAT gateway. And so the entire focus on Amazon is shifted towards using NAT gateway, but that is unique to only Amazon. We will use this, but I don't want you to think that this is a requirement. The requirement is you need to have a router. You can get a router from wherever you feel like. And that is what I'm trying to highlight. The point being, you don't have to use a NAT gateway, although I would say that this is a good solution, but you don't have to use it. I'm telling you the ideas that you can apply to any cloud provider, any whatsoever. So Google, Amazon, Microsoft, whatever, you can apply the same concepts across the board, which means we are going to NAT shop. So I'm going to look up a couple more words: Amazon, AWS, NAT device, AMI. Okay. Let us see if I find an AMI number. Okay, Amazon provides Amazon Linux AMI configured to run NAT instances. These AMIs include the string. So that is the search string. Amazon AMI VPC NAT. Okay, click in their names. So you can search for them in this section. So the keyword to search according to Amazon is, that is what you need to search. I just pasted in Slack chat. The keyword to search is, I just pasted, which means I'll go back to here and search. And we should find nothing. How crazy is that? They're hiding or what? My AMIs, quick start, community AMI, let us go search. In the community, we'll have it. There we have a couple of them. So we will select 2015 to look for newer versions, maybe 2016 to see if there is an even newer version. And there it is. So that is the AMI I want to use. So the keyword to search appropriate machine image for use in the Amazon cloud with a cheap version of a router is that string I just pasted, which is Amazon AMI VPC NAT 2016. There are three results we are looking at right now. You will see that these three results are pretty similar to each other, except this is March. This is March number 2. This is March number 1. So we'll select the latest and greatest, which is March number 2. And that is the AMI I want to select. This machine, which is created in March 2016. It is 64-bit. And that AMI is what I want to use. When I search that string, I find it in the community section. In this section, community AMI. The search was Amazon AMI VPC NAT 2016, and it popped up. I'm going to look at this item, 3.2 specifically. So that is a device that I want to select as my router. This runs Amazon Linux, which is Red Hat Linux. So it is practically a very, very cheap machine. So I'm going to select it. I'm going to get T2 Micro, like that one, which is like free for you. And I will then proceed forward with configuring the instance. I am going to make sure that I select my network VPC is CloudGenius. Double checking whether I'm still recording or not. I am recording. Good. So what I'm going to do is in the CloudGenius VPC, I'm going to select my BC subnet. That's what I want my router to be, in the BC subnet, not in the private subnet. Not here. I want it to be in the BC subnet. Click. And in the BC, I want to make sure to get a public IP.
A question, Nilesh. So, didn't we say that in the configuration we designed earlier, public subnet, which is BC, is connecting directly to the gateway, but the private subnet is connecting via the router to the gateway, right?
Yes. Yes. So right now we are buying this box. We are buying a router, placing it right here. Okay, we are buying this machine. We'll create these machines later. Later.
Okay.
Right now we are creating this one. So we want this machine to be the specific type of AMZN-AMI-VPC-NAT and space 2016. That is what I searched for. And I get this Amazon Linux machine image for use in VPC as a NAT device in the year 2016, March 0.2. That's the machine I'm picking right now. And I'm going to create this box right here, which will give me a router. I want the router to be on the BC subnet, not yet on the private. I don't want a router in the private area, not at all. I want it to be here. So that is what I'm doing right now. CloudGenius VPC, BC subnet. Get me a public IP address, enable. So this will get me a public IP address from my gateway. I want a public IP for my router, right? My router belongs to the world outside. So people, including the bad guys, can at least up to here come. And then I will decide whether I want to accept or reject. That acceptance and rejection will happen at the level of router in this design. For that, I need this router to get a public IP address on the internet using the gateway. And that is what I'm designing here. I'm selecting CloudGenius VPC, BC subnet, enable public IP, add some storage, magnetic, no, SSD, okay. Cheap SSD, not the expensive SSD. So I want to get the cheap one. Tag it. I'm going to call it my router. Right? This is my router. So I'm going to call it so. Configure security groups. And here I will identify if I have an existing security group, which I don't. So there's only one group called default, but I want to create a new security group and call it my router security group. That's the name I want to give. And then I will edit the permissions later. But for right now, for TCP 22, anywhere on the internet is a good one. I will edit them later. I'm creating a specific custom security group setting for the router device right now. and then I will review and launch. It says my security group router is open to the world, and I understand it should be like that. And so I am going to launch it. I'm going to use my key pair called, I don't have it. So that's a problem. I need to make sure that I will get my key pair from this machine and give it to Amazon. They don't seem to have my key pair, which is a problem that I will run into if I go ahead without it. So I copied my public key, go to Amazon, go to the key pair section, which is in EC2, and give them my key pair import, call it ID_RSA, and paste, and then import. Now this represents my key that I have in the workstation, which is good. Now I'll go back, buy the router. My router is available in EC2, and in the EC2, I will find launch an instance, community AMI, Amazon, and NAT VPC 2016. And here it is, that one. That's what I want to get. So I will say, okay, T2 Micro, okay, Cloud Genius, yes, BC, yes, enable to get me a public IP, yes. 3 things: correct my VPC, make sure I am on the BC subnet, the outside subnet, public subnet, enable a public IP address, proceed to add some storage, convert into SSD, tag the instance, call it a router. So that gets me a router, and configure the security group. I'll select an existing security group, which I don't have, so I'll create a new one. I'll call it the router. And then I will leave the rules as open to the internet, no problem. I'll edit it later. But for right now, remember that the name of my security group that I'm assigning to the router is the router. And with that, I will review and launch, and select a key pair called ID_RSA. And I say, yes, I know what I'm doing. And then I launch. So now I have a router, this one, and it is sitting in my VPC. As you can see, it sits in the VPC ID, which corresponds to the Cloud Genius VPC. It is a Amazon AMI VPC NAT HVM blah blah blah. So it is not Ubuntu Linux, by the way. It is Amazon Linux. It has a key pair ID_RSA that I know. It is in this router security group, which we just created. If you view the rules are allow access from anywhere on the internet using SSH protocol, port number 22. Okay, we now have a public IP address. We will remember that and copy it, because that is the IP address for my VPC's router. That's one thing that I need to remember, that this is the IP address that I have been given from the gateway that I have created. Now, having created that IP address and the box, which acts as my NAT device for the VPC, I need to go back to my VPC section here. In the VPC section, I will go look at my VPCs and filter down to the Cloud Genius VPC. And in here, I will look at the route tables. You will see that my private route table, the routes are limited to only within the VPC using the local connection. I want to expand it and allow another route to have it go anywhere on the internet, but using my router. There it comes. It pops up.
Cool.
And so I'll select the router. And this happens to be different from the gateway. And when I save, you can see that this route is going to the internet, but not directly. It is going through this I-C21BB71F. The BB71 Fox is the instance ID for the NAT, the router that I have placed here. As you can see, it is the BB71 Fox ID. That same machine is running, is acting as my NAT device, my router device. It is sitting in the Amazon VPC that I created. Like, I'll try it one more time. So we have a VPC 10.0.0.0/16. We have a subnet, call it BC 10.0.0.0/24. Another subnet, call it private 10.0.1.0/24. So this means you can play around with this number, anything you want. You can play around with this number, anything you want, and have the machines get that IP address, which means we have now placed a machine right here. We call it the router. So the router should have an IP address in this range. Let us go check that. What is the IP address for the router? It should be like this: 10.0.0.0, 10.0.0/something. We don't know what. That is what we will find once we go and check the internal IP address of the router device that we have now. So go here, router, what is your private IP? It says 10.0.0.0.55. Yes, we have it done correctly. So the address that this router got was a part of the subnet routing. We got 10.0.0.55. Fine, good. This router is connected directly to the internet. So it has a public IP also. What is your public IP? The IP is this. Great. This device that we purchased or rented is a router. So it will act as our router, as you know, which means we can clean up some of the aspects here and try it one more time to understand what we are going to do with it. The scenario again is that we have this VPC, which has this entirety of the address space, in which we have two subnets. One of them is 10.0.0.0/24 and 10.0.1.0/24. And here we have taken only one machine, put that on that subnet right here. And it is connected to a gateway, which allows it to connect to, boom, CNN or whatever, XYZ, Cloud Genius. It will go wherever you want it to, but that is going through the gateway. Now, if you want to reach this machine, what will you do? You can, sitting right here in your office, you can connect like this and go here. How? You'll grab the IP address, the public one, go to the workstation right here. And say SSH, and then username at IP address -I. That's how it goes, right? You know this already. So I will do the same, except that the username is different. It is in Amazon Linux, it is EC2-user. And the IP address is this. And now we should just hit enter and say yes. And we are connected. We are connected to the Amazon Linux AMI. And here we are, the internal IP address is 10.0.0.0.55, which is exactly what you see right here, 10.0.0.0.55. And this is no big deal. I mean, yeah, we connected to the machine directly. It is on the public subnet. We have a public IP address, whatever. Who cares? We have done it. We have done it before. No big deal there. The big deal, or rather the interesting scenario, comes from the fact that you create a machine here in the private area and still sitting on your laptop, connect to the gateway through and through like this. And that will be fun. That is what we will do next. And you know, this is private area, which means there is no direct route from here, from your location, all the way to this box that we will create now, just like that. Launch an instance, Ubuntu machine, configure the detail, use my Cloud Genius VPC, and put it private, not BC, private. And by the way, I don't want a public IP. Do not give me public IP. Auto assign public IP, no. Add some storage. SSD, good, tag the instance. This is my work server. I call it whatever you feel like, it's a name. Security groups. So I'll call this security group different from the router, but a new group. I will call it my workhorse, a work server. And in there, I will say, allow SSH traffic, but only within my subnet. Like, only within the subnet. If you are within the internal VPC, you are welcome to connect. Otherwise, you are not. And that is my modified, customized security group for my work machines. This work server sits in my private area. It does not get a public IP, which means I cannot reach that box directly. However, I know there is a route. The route is through the routing table, through the router device I have. There is a route like this. So if I create a new box here, which I call it my work server. And so this machine, I'm creating a security group that says, you know what? Anybody who is in that security group called work server can connect to this box as long as they are within the VPC. You're welcome. You're in the island, you're welcome. Outside the island, you're not welcome. You can get lost. That's what I'm saying here. Is 10.0.0.0. I'm saying that, you know, you can come in if you feel like, but that's one way to say it. Another way to say it is that I want to say custom and say, I want to call it the Cloud Genius VPC. And so for that, you need to get the VPC ID. The name doesn't seem to respond. So I'll go grab the CIDR notation, the IP address, or the security group name. The easiest way is to just allow the entirety of the VPC to come into the work area and not anybody else outside. That's the simplest way to think about it from a security standpoint. Anybody within the VPC, you're welcome. Anybody outside the VPC, get lost. And that is why this representation is a simple one for the security group that I'm going to create, and I'm going to call it work server, or I'll call it my working area. And that is the name I'm going to choose, working area, and then review and launch. And then I launch it. When I launch, I want to select this key pair, and I acknowledge, and I proceed. So now I get a box, or rather another box, I should say. So I have now two boxes. One of them is the router box, which you saw already, and I'm connected to it already like this, as you know. So the router box, I'm already connected. This one and the other box is getting started. This is the work server. It runs Ubuntu Linux. and it has the security group called working area. And the rule corresponds to let me connect only if I am within the firewall or within the VPC, not anywhere else. So you get that. That's one way to write that thing, like 10.0.0.0.16. Another way is we will discuss various alternatives to explaining and understanding that. Now, for now, we know that we have said, don't give me a public IP at all. But I still want to connect to it. I don't have a public IP. How do you think I'll connect? I don't even know what to type here. I have no idea. How will I connect to it? I know that I can connect. If I knew the public IP, I will say Ubuntu at that IP.
You mean to the the workstation you connected?
Yeah, the work server I created, right?
Mm-hmm.
I want to connect to it. I don't even have a public IP, so how will I reach there? So that IP address that I don't have, how will I go there now? And that is the question I want to resolve. And for that, I'm going to introduce a new concept. Concept is called tunneling. Tunneling. We are using an SSH-based tunnel to first, from our location, connect to the NAT device that we know we can do already. And then through that, tunnel it into the other box. And that tunneling method is what I'm going to demonstrate. Most deployments will use a separate box for tunnel. So they will call it a tunnel box. Very, very similar to NAT, but the purpose of these devices is distinct. And most companies, most deployments prefer that you have one dedicated role assigned to one little box and ask it to do just that thing, and don't muddy the water. Don't mess with other ideas such as mixing the tunneling role with the NAT role with other things and traffic. It gets complicated. So people, and the best practice is to separate the NAT role from a tunnel role. However, at this moment, I'm just for the purpose of demonstration using the NAT device we already have as a tunnel. That is the idea. In practice and in best practice, you will basically create a separate box. You will call it a tunnel box. You will call it a bastion box. You will call it a jump box. You can call it whatever you feel like, but the idea is it's a separate box. Don't mix with the NAT function. NAT has a specific function, which is to allow traffic from these guys to go outside. If they want to go outside, don't prevent them. Let them go to CNN, but don't let the bad guy go in there. No. That is the function of this router. So let it do that job. Don't mix and match tunnel function with the NAT function. That's the best practice. Having said, let us understand how will we tunnel. So to tunnel, there is a specific method already built into SSH. And there is a configuration already provided to you in this folder. In this folder, you will find that there is this config.example. It's built in for us to use. So we'll open it up. You will see that this file actually expects a jump box, an internal box, another internal box. So 3 boxes. And instead of, like I said, the best practice is to not mix the role of tunneling with the role of NAT. I am actually going to not use the NAT box as a tunnel box, but instead create a separate box just for the purpose of using as a jump box or a tunnel box, and not go like this at all. Which means I will change my plan and actually walk you through the best practice as opposed to mixing the two ideas together. So I'll clarify that one more time. I think it is a better idea to just show you the best practice instead of mixing it up. Technically, you can use the NAT device that we now already have to jump and go like this and use it as a tunnel, SSH tunnel. You can do that. It is technically possible. However, it is not a best practice. And therefore, I'm going to create a separate box dedicated for jumping. I will call it a jump box. Pretty similar to NAT, except it doesn't have to be NAT and it does not participate in the routing table. Only function is to allow us to jump from our workstations all the way to the machine's internal. That is the purpose of this box. You can use NAT, as I said, but using the NAT as a jump box is not a good idea. So we are not doing it. No, not doing it. So which means we need one more box, which means we go here and get a box and go to Ubuntu or yeah, why? Let's get some flavors. So let's get some flavor here. Instead of Ubuntu, I'll select Amazon Linux. I'll select launch an instance and select Amazon Linux right there up on top. This one. It is basically Red Hat Linux. Amazon Linux has a branded version of Red Hat. Pretty much it is Red Hat. Think of it like that. This is very similar to this, except Amazon Linux is cheaper. Red Hat is expensive. And so is SUSE, whatever. That Linux is also expensive, a little bit expensive. Ubuntu is cheaper. Windows is expensive. So I want you to be aware of the pricing aspects as we go along. Amazon and Ubuntu are cheaper. Red Hat, SUSE, Microsoft, they're a little bit expensive, like a couple of cents on an hourly basis. Having understood that, to give you a little bit flavor, I'm going to use the Amazon Linux AMI. This is a generic machine. It is not a router, just a machine, no router involved. I'm taking that machine, selecting it, T2 micro is good enough, and putting it in my VPC in the BC subnet, by the way, because this jump box also needs to be on your public area. You need to be able to jump. So I will put the jump box right here, like that. And instead of jumping like this, I will jump like me or you. I will jump from here. Wherever I feel like. And this router, we will leave it primarily for the purpose of outbound access for these guys. That's the purpose of router. So leave it with that function in life. We'll create a separate box called jump box like this and mount it right in the BC subnet and connect to it like this and use it as a tunneling device so that we can go inside to the work servers that we might have, hundreds of them, how many number of them, and then connect to them. So that's the goal of this jump box. We are going to be the Cloud Genius Works VPC, BC as the subnet, enable public IP. We want to get a public IP address so we can at least reach the jump box itself and then jump through the jump box inside. So adding some storage, SSD is good, tagging it, calling it jump box. and then security group. I'm going to call this security group my jump box security group. And in here, I will allow access from anywhere on the internet so that I can come in, only opening one port 22, reviewing and launching it. And when I launch, I'll select my key pair and acknowledge and launch. Then I get a new jump box right there, here. You see that in my EC2, now I have 3 instances, and they are the router, the jump box, these 2 guys, they are on the BC subnet. Work server is not. Okay, so where is my work server? I have in my design a VPC, I have a router, I have a jump box, and I have my work server here. This is the BC subnet. This is my private subnet. And that is what I have up until now. I have a gateway here. And this has a public IP address, private IP address. That's the machine set I have. So I need to be able to connect from here, go first to this location, and then figuring out our tunneling strategy or jumping strategy to connect to any of these machines here, W1, W2, W3, all our work servers that we have inside in the private area. We will connect to them. But for now, let's verify whether we can connect to the jump box. As you know, our jump box is also an Amazon Linux, and the rules are connect from anywhere, port number 22, you can come in. The IP address is right here. So grab the public IP address for the jump box for this one, and then go here. One more thing, when you're working, you should not work inside this directory, never. Do not work here. Do not work in this folder. You always want to come out and then go to another folder, or maybe work in the home folder, but do not work in this folder. Don't mess with it. Leave it with the keys and configuration and known host, and work somewhere else, ideally in a folder you know. So you should remember what location you're working on. That is why I have this prompt here to point out where you currently are. It says user is in tilde. This tilde means you are home. And that's okay to work there, no problem. So having understood, let us connect SSH, user, that IP address, right? You know that method that I have seen you used in the past. I want to use the same method, except the IP address. Let me clean again. So SSH, username at IP address, and then -i, and then the file name. That's how it should work. So we'll go fill it up now, SSH, and you know it's an Amazon Linux EMI, which means the username is this, and IP address is this, and then SSH, and off we go. We should connect to the jump box, and we are connected to the jump box. Right now we can see that the IP address internal is 10.0.0.0.170. That's the IP address we have. This 0 tells you that we are in the BC subnet. This 0. You can tell very clearly because that's how we designed it to be. This 0 tells you that this machine called the jump box happens to be in the BC subnet. And that's how we connected to the jump box. No big deal, no big deal. Now let's come out of it, exit. Now back in our .ssh folder, there is this file that I mentioned before. It's called config.example. And that is something that I would like you to review. The idea is that we have this jump box that we created. We have an IP address, which is from a previous example. So we want to modify that. it also indicates that it is going to act as a forwarding agent for SSH traffic to be forwarded. We are going to use the identity file in our home folder ng.ssh location with the name IDRSA. And the username for Jumpbox is EC2 user. The machine inside we have in our VPC might have a different IP address. And here is the key operative command for proxy, which is using SSH as a proxy command to jump all the way in one shot to this location, internal location, using the jump box, using the forwarding agent, and using the same identity file that we have, except the username of the machine internal, this internal box, is not EC2 user, but Ubuntu. And so this is an example file. We want to take this example and create our own customized version for which we need to copy it into a separate file. So we will go to that folder, and in there, we will copy config example to a file called config. That's it. Just copy into a file called config. As a result,
is that a handcrafted thing? The config thing is a
yes,
handcrafted file, right? Yeah.
We have to handcraft this file. This is just an example file. So we copied the example into something that we will edit now. So we will edit this config file, which is a copy of the example. Okay. I just copied the example into this file, and I want to modify this config file now. So I'm going to open an editor and edit that. So the editor is opening up, and I see that in my editor, I have the couple of files there that I'm going to look at. The most important one I'm going to look at right now is the config file, which has a reference to Jumpbox, but the IP address is wrong. So I will delete that. Instead, I'll paste the IP address that I know from my Jumpbox, which is this. So I'll copy the IP address from the Jumpbox, take it over here, and paste it. Next one, I will make sure that this is EC2 user, because I know that the Jumpbox is Amazon Linux AMI. So this needs to be EC2 user. I have one machine inside, I call it my work server. So this machine IP address needs to be known. We need to know where we are headed. So we have the machine, a work server, which has an internal private IP address like this, 10.01.44. This one indicates that it is a private subnet. Not only it's a private IP, but it is a private subnet. So we want to put that IP address right there. And we don't have this machine at all. So we'll delete it and save. Having modified our file with IP address for the Jumpbox, making sure that the EC2 user shows up for the machine that is this operating system expects. The IP address for private IP address for the machine internal to the private subnet is correct. The username for that machine internal is Ubuntu. So we have put that there, and we'll save the file. We deleted the third entry that we don't have anymore yet. So we close it. And then we quit the editor. At this moment, I want to come out of this folder. I don't want to work here. So I come out. CD, enter, that comes out. So back in this location, tilde. Now at this moment, I want to test a couple of things. First one is again test whether I can jump to the Jumpbox, which I know I can do. I can go here, no problem. The question really remains is, can I go here directly? And the answer is, with a tunneling in place, with the configuration that we now have, yes, we can. to illustrate the point very, very clearly, I will erase one file. that known host file, I want to get rid of, so that it illustrates the point of jumping very, very clearly. You see that I have deleted my known host file because I want to demonstrate the fact that we are actually jumping because the known host file does not exist anymore. Your question, please?
Yeah, so, okay, got it now. So we have a jump box. So, so we have a jump box in the public subnet, which is the BC subnet. And then we have a workstation, work server in a private subnet.
Correct.
So the idea of the jump box is from your workstation or from your terminal, you would be able to directly jump. You would be able to directly hit the work server via the jump box.
Yes. There is otherwise no route. There is no route to go here. Because these box that we have, the work server, we don't have a route. We cannot be here, right? We are not in the VPC. We are outside the VPC. So we want to go there in the private area. The only way we can go is through tunneling.
Mm-hmm. So the route is added, the jump box route is added to the
So this line helps you jump. It is the SSH proxy command. It will help you jump from the jump box through and through to the internal machine. And you will see that in just a moment.
Okay.
Nilesh, questions to you.
Yes.
Why you want to delete the known host? What is the benefit out of it?
The benefit is to illustrate you the point that we are actually jumping. Otherwise, you will not see the jump steps.
Okay.
You don't have to delete it, but I want to
But if you would not delete that, still you can jump it, right?
Yeah, you can still jump. But I want to show you.
I just want it clear. Okay.
And that is why I removed it. So now I want to connect to SSH. And then say this IP address. SSH. And say, here we go. Can I go to my work server? In practicality, if you do not have SSH configuration like we just did, like we just created, and if you try to run this command SSH in an IP address like a private IP address and hit enter, it will fail. It doesn't know where you want to go. But our SSH configuration that we have now enabled for jumping allows it to know what you want to do. And that configuration you can see in this example. I'll keep this side by side so you will understand it very clearly. Hold on. Let me put this side by side. So this is SSH configuration on the right side, and this command is on the left side, right? Here we go. So we have the command on the left side, and you can watch the SSH configuration on the right hand. Now you will notice that this IP address 1.44 is the same that we have here. That is what I want to connect to. Normally in the absence of this file, if you don't have this file, config file correctly created, you will find that this command will fail. It doesn't know what to do. However, if you run it like right now with the configuration in place, it will read that configuration and understand that to go here, it needs to actually run a proxy command SSH through the jump box. And what is jump box? And how do you connect to a jump box? You connect like this. You go to this IP address first, and you use this key and this username to connect to this box first, and then jump through and through that box, through proxy to this box using this username and this private key. That's what you will see just now when I hit enter. And here we go. First one, Click.
Wow.
Says,
Hmm.
it says, I don't know what this 154202 is. It says, I don't know who this guy is. I mean, I know who this guy is because I created the jump box. So yeah, I know what you're doing. Go ahead and do it, please. So that's a yes answer to this question. I know I need to go to jump box, so please shut up and go do it. So I'll say yes. But then I have deleted my known host file. So it will ask me this question one more time for the second box, which is the jump, like there. It says, 10, 0, 1, 44. I don't know what you're doing. And I can tell that, I know what I'm doing because I want to go here. And so I want it to go proxy command in one shot with this one command all the way internal. So I will say, yes, I know what I'm doing. And yes. And so here it goes in one shot all the way to the machine inside. And you can see the IP address is 10.0.1.44. And it runs Ubuntu.
Okay, wonderful. So, so with this command, so from jump box to the work server, it is by means of tunneling, right? By means of SSH tunneling, 22 port.
SSH tunneling, correct. This concept is called SSH tunneling. That's what we just saw. Now, however, I will just exit out of here. So exit. Oops, hold on. I'll go back to the terminal and say exit. So it came out. Now I will remove this file called config, and I will maybe rename the file to something else like config.don't-use. Okay, so we don't have a file called config now because this is called config.don't-use. It is not the config file, right? So we just renamed it for clarity. I'll rename it to do not use, right? So we don't have a configuration file anymore. Now back in terminal, I'll say, oh, I want to go to the internal box one more time. It says, I don't know what you're talking about. I have no idea where to go because you don't tell me where 10.0.144 is because it's a private IP address and I don't know how to route to it.
Okay.
So it does nothing. It gets stuck and it will fail after some time saying, I don't know what are you doing? What are you talking about 10.0.144? I don't know. And so we break it. And it's not going to work unless you have a proper configuration in place like this. We have to rename it back and call it config. And then we come back here on terminal and say go, and it just connects it directly in one shot all the way internal to the internal private IP, private subnet. And that's what you see. There. Now, this doesn't conclude our discussion, by the way. We still have a couple of things to understand and a couple of things to really, really comprehend. And it's a good time to take a break. Yes, it's a good idea. Thank you for the reminder. So at this moment, I will take a short break. Right now we have 6:43 p.m. We'll resume at say 6:47 p.m. Whatever did I write here? Hold on. 6:47.
That's short break. We should do 6:50.
Okay, you just 50 is fine. Yeah.
Okay, thank you.
I am very stingy. No worries, no worries.
Yes. Thank you.
Okay, man.
Oh man. Oh, sorry. Excuse me. I'll go grab water. Hold on. So I'll be back at in just a minute, but stand by, please. Thank you. Okay, so we are back, and there is a question in Slack chat. The question was, as you can see in the Slack chat, connecting from jump box to the workstation. Is the ID RSA file from the machine that initiate the SSH get used? Okay, so the paraphrasing that question, the question is, what happens to the key, the private key? We have this public key that we are using in, I hope you can hear me. Just wanted to confirm that.
Yes.
Okay, good. So the question is, this key that we have, the public key and the corresponding private key that I don't want to show anybody. I want to keep the private key private. Those key pair, that private and public key pair, how does that get used? We are connecting to internal box, and then we don't even see the jump right now. It just directly connects. So how is the key getting used? Who's going to actually provide that all the way? And so the question essentially boils down to, if I paraphrase, how does this jump box pass the authority to connect to the internal box using a key? And the answer is that the identity file is placed in this folder right here, which is this key is what is getting used. And it does not go away from our laptop at all, ever. This is the private key. We want to keep it on our workstation and don't even want to give it to the jump box. So no, the jump box does not have the key. In another design, you could, in another bad design, you could copy the key, this private key, and give it to the jump box. So like, for example, SSH jump box, and we will connect to the jump box right there. We are connected to, by the way, you can see that the simplification that has happened, SSH jump box, it just automatically goes there. And that you can enable because you don't have to type in the key name and the username and all that. It is implied in the configuration itself. You can just easily go to SSH jump box or maybe come out of it and then go there again like this. And when you are in the jump box, in a bad design, you could, bad design, bad, do not do it. But in a bad design, you could do that in this folder, in the remote jump box. You could paste private key here. And in that location, then you can go another SSH and 10.0.1.44. Possible. Yeah, it will fail because we don't have the private key, but technically possible to do it that way. It is a bad design. You can go something like this, SSH Ubuntu at 10.0.1.44, then pass the private key, stored locally on the jump box like this. And we don't have the key there because we don't want to give our private key even to our own jump box. Forget about anybody else. I don't even want to give my own jump box my private key because I don't want to give it. As simple as that. So I'm afraid that if I give my copy of my private key to the jump box, that I might be compromised, because what if somebody takes over my jump box? I will be screwed. I don't want to get screwed. So I want to not give my private key even to my own jump box. And that is why this method, although technically feasible, is a bad idea. You don't want to copy your key over to the jump box. If you do copy, it will work. Right now, I don't have the key. So if I hit enter, it will fail. However, to illustrate that it works, I will copy my key. But let me warn you that this is a bad idea. So I will rather not do it unless you want me to. So I'll exit from here and say SSH. And that way, I can just in one shot with a hop. So there is a hop involved. the hop takes my authentication from my locally stored private key and takes it to the jump box first, and then jumps from the jump box all the way to the inside machine in one shot. Never gives my private key out. You see that? And one shot goes all the way in. So this is a simple tunnel method.
Okay, Nilesh, in this case, is this machine saved under known host?
Correct. So let us understand that. I'm going to exit from here and
Uh-huh.
look at our known host file.
Okay,
You have two entries there.
right.
Those two entries are corresponding to the two machines that we ran into. One of them, jump box. Second
Mhm.
one is the internal machine. So one of these machines is the jump box, and the other machine is internal to the private subnet.
Correct.
And if you delete these two lines and save, and then try to connect again, it'll ask the same question. I don't
Mhm.
know what you're talking about. 154.202. Who's this? I don't know you. So we'll say yes.
You delete your history.
And then it says 10.0.144. I don't know what you're talking about. This, whatever. I don't know it. So we'll say yes. And it goes in. And it connects.
Mhm.
Right? So that's one way. Another simplification you could potentially do is something like this. So you can go like host name and call it work server. That should also work. I just modified the syntax a little bit. And in here, what I'm going to do is come out, right? Remove this known host entries, delete, save. And my configuration looks like a name as opposed to an IP address. And now I'm going to say SSH work server. It says, who is this? I don't know. I say, yes, I know. My jump box. It says 10.144. I don't know. I say, okay, go ahead. I get connected. Right? So back again, exit. I can very easily say SSH jump box, and I connect. I come out. SSH work server. I connect, and I come out. However,
So you can rename whatever you want.
yeah, exactly. So the idea is that this configuration helps us jump like this. So this is all about us jumping around here and there and going and connecting and all that. But what about traffic, like IP traffic, like machines trying to update themselves, for example? So we have this work server, which is an Ubuntu box, right? And I want to run some updates on the box itself, which means I need to have that machine, this work server. I want to have that work server connect to the internet. Can I connect to the internet from this box? I don't think so. Let us see why. So we'll go sudo apt-get update. Boom. It says connecting, and fails. So it is not able to understand where to go. Because even though we have said that you can go to this IP address using the NAT or the router that we have put in place, it still does not have the security group permissions to go. And so it is attempting to connect, but the security group is rejecting the connection. Let us understand this aspect. So I will break it now and go back to our illustration of security groups. So the security group for work server says the view rules. It says only port number 22. The traffic is on SSH only, and it can go from anywhere within the VPC. And that's the security group for this box, work server. Now we need to modify that. We need to have conceptual clarification made for traffic to flow properly. We know we have taken our routes so that our work server can connect to the jump box or just about anything on the VPC. We have this VPC. We have a border check subnet. We have a private subnet. And so the idea is that we want to be able to have these guys connect among each other. And that is totally possible because we are saying that 10.0.0.0/16. Okay, we have said that. However, we have to make sure that the traffic is allowed like this. And it goes to the internet. So the www worldwide internet that we have, like CNN.com or Ubuntu.com or whatever else you want to go, you want to be able to go, have this box go, for which we want to make sure that we clearly understand security groups, which means we need to allow this and this security groups. Specifically, we have a security group for our router, we have a security group for our jump box, and a security group for this guy. We have 3 different security groups for these 3 different boxes. Let us understand those things. So the first box, work server. The security group is called working area. And the rules are very, very narrowly focused on just port number 22. And it says, yeah, you can come in from wherever you feel like as long as you are within the VPC. So only SSH traffic is okay to come in. Okay to come in, but we are talking about going out. We want to go from here to ubuntu.com to update the box, update. And so we are talking about that kind of a traffic, which is not SSH. So we have to understand that traffic clearly and then make sure that the update for Ubuntu works. Right now, it doesn't. As you saw, this Ubuntu update fails. It's attempting to connect and fails because the security group does not permit. So we want to make sure that we understand what is missing and add that. So now back in our design in the piece of paper, what I want to be able to do is not focus too much on the SSH traffic, but general HTTP traffic is what I want to focus on. And I want to make sure that this machine actually is allowed inbound access to this security group, the router security group. So router should allow traffic to come into it as long as it is coming from the work area. So we will open that access. We'll go to the router security group. Currently, it shows only SSH from anywhere on the internet. So we want to go modify the router security group for inbound routes, which shows TCP access only from port number 22 from anywhere on the internet. So we want to expand that and add a rule to allow all access, all traffic, as long as it is coming from working area. You see what I'm doing? I'm typing the word working area, which pops up this entry. And so this is what I'm doing is allowing all traffic for inbound into the NAT, into the router, if it is coming from the working area, like this. And working area is the name of my security group for machines that I will put here. Right?
Also, that means the router now will accept any traffic from any of the machines you put on the working area security groups. Any machines you put with the, okay.
Correct. Because I want the router to actually listen to what I'm saying. So I'm saying that, you know, if I have machines here in the working area, please allow me to go out. That's what I just did. Allow all traffic on all protocols and all ports if it is coming from the working area. Interesting idea. Okay, let's see. So we go back here and say apt-get update. What's happening? Let us study that. It's still not responding, right? So we will break it, study that thing again, and look at other security groups. What do we have? All of them. Let's examine them. So let's focus on, there are too many groups that might confuse you. So I'm going to clean up, or rather just visit them one at a time instead. So go back to the running instances. We have to look at the router security group one more time, view the rules. It is still not updated here. So I'm going to refresh my screen. And now go back to the router, look at the rules section, and now it shows all traffic allowed as long as it is originating from this location. Great. Now we'll also see on the work server, the working area security group, what are the outbound rules? And it says, yes, you can go anywhere on the internet and all traffic. So that's a good one. So that's what we are looking at. All the traffic from this location allowed to go anywhere you want. On the other section we had in the router security group, the rules are to allow all traffic to go, to come into the router security group. And what about the router security group's outbound rules? They are also open to the world outside. Inbound, you're allowing traffic from the working area, which is good. Let us also see the working area. Inbound is okay. Outbound, you're saying go anywhere you feel like. Router outbound, go anywhere you feel like. Router inbound, and it is coming from working area, that is okay. So let us understand this one more time. Still, we must be missing something, or something else is happening right now. It is not allowing us traffic to update, which is crazy. But let me clean up some of the unnecessary security groups in the meanwhile here that are not needed. So I will clean them up to reduce confusion. From older times, we have these security groups. I want to delete them. Oh, I think they're used for something else. We'll leave them alone. These other security groups are used for something else in the cloud, apparently. So I'll leave them alone for now. Let us carefully understand the security groups related to the work area as to why it is not working. It should be allowed. Hold on. So working area, inbound routes, and outbound routes, they're clear. And the NAT area, the router area, router security group, outbound route is open, inbound route is also open. It should work, but it doesn't seem to work. It should work. So we are going to reboot this box. And the box reboots and the connection breaks. We are back to our workstation. We are attempting to connect to the jump box first. Make sure that the jump box is still active. Yes, it is. We'll attempt to connect to the NAT device also. So the NAT, which is the router box we have here, 3 running instances. The router box, the IP address, we want to grab that and go to connect to the router directly like this, SSH, EC2-user at IP address -I option -SSH ID RSA. It should connect to the router box, which we see that it is connected. Let us check whether the router itself can update. The router is an Amazon Linux, which means we have to update using yum update. And let us see if, okay, sudo yum update, which means this box itself should be able to update. And I think it succeeded. Looks like the update succeeded on the router itself. Let us see if we can ping CNN.com from the router. No, No, not working. So which means we have to look at our outbound traffic rules one more time. So go back to the router and router security group. Outbound traffic is allowed to every destination. And we see that our pings are not responding, which is crazy. Something wrong. Break again. Ping, this time google.com. Does it ping? Yes, it responds. Nice. So traffic, as you see, is going out from the router over to google.com, which is good. How about ping? And this time go to yahoo.com. Does it respond to pings properly? Looks like it does, which is nice, which means our router is able to connect to the internet anywhere on the internet, as you saw in these two examples. We'll come out of the router and go SSH to the work server, or rather jump box first, and see if our connection to the work server actually succeeds. So SSH and work server is where we are right now. We are back to the Ubuntu box inside in the work server. We'll check one more time in the example, which is back to our dashboard. Go to 3 running instances, look at the work server, look at the view rules, and we can see that it allows inbound traffic. We look at the working area security group for outbound routes. It goes anywhere you want. Inbound routes allowed for port number 22. We'll look at our other security group for the router itself. All traffic allowed from, as if it is coming from working area, allow that. Outbound route, go anywhere. Now, having done this, let us see if we can update our boxes. And it is not allowing us, which means there is still something missing or something else is fundamentally broken somewhere else. We don't know. We have to diagnose these things. So at this moment, let us see back to our routing table. Is that routing table still accurate? So we'll go back to our VPC. In our VPC, we'll identify our VPC by that name, Cloud Genius. Then look at our routing table. Look at our private route. See if the route is actually connected and active through the NAT, which it is. See if the subnet association is with the private. Yes, it is. What about BC? Is the BC association correct? Yes. What about BC routes? Is that gateway connected? Yes. So why does that not connect? Why does that traffic not flow? To further diagnose this, I suggest opening up a little bit more. How do you open up the security groups? Again, go back to the security groups we have, which are here. And the focused areas are router security group. We want to allow outbound access, which is already wide open. We want to make sure that our working area security group is also wide open. So it should allow the access to anywhere, but I'm making this modification like right now. I'm allowing router access for all traffic from any location to see if this makes a change, or otherwise our machines may be bad. This happens occasionally when in the cloud, you might have, especially when using T2 micro small machines, very, very small, cheap machines, you run into these problems occasionally. And I have seen this many, many times. Is that when you're dealing with cheap computers, you don't get all the resources available from a cloud services provider because they don't pay too much attention to these cases. Sometimes they throttle you for resources because you are not paying them money, so they don't actually give you the best level of service possible. Having said, let us understand how do you actually run into this issue and resolve it. So what I'm attempting to do is in the router security group, I have managed to open inbound access for all traffic from all locations. This is just opening up the whole thing. And working area, I'm allowing outbound access to all locations. Inbound access, I'm making it open for all traffic to anywhere. And this is just to open up the whole gates to make sure that we are testing the machines are working correctly. So all the inbound routes are open on the working area. You can reach it inbound, all traffic, outbound, all traffic. Same for router, outbound, all traffic, inbound, all traffic. Everything is open. Now that entire route from this machine through this machine all the way to gateway. All the ports, all the protocols for all IP addresses are open. And this is, I just opened it up because I want to test whether the machines are performing properly or not, or is it some other issue. That's what I'm trying to narrow down by opening up all the gates in security groups. And having done that, I will go back to my machine in the internal box, this one, break this one, clear it, and then attempt to update one more time. It is still failing. Now that is an indication of something fundamentally wrong with the box.
Could the box has firewall? I mean,
sorry, box has what on?
Oh, I'm just thinking maybe this box has firewalls, OS firewalls, like IP tables or something like that that block it.
So yes, possible. Good guess. But most machines in the cloud expect you to turn on IP tables. They don't give it on for you to begin with. So the IP tables are turned off to begin with.
Oh, okay. All right.
The IP tables are not on. They're not on.
Nilesh,
Yes.
do you want to try with your Mac computer terminal?
Yes, but I don't have the keys in there. And I think it's not a Mac issue. I think the issue is with that machine out there in the cloud. So I will basically kill that machine. Like this work server, I will say, you know what, you go away. Like that. And then launch another instance. And I'll say Ubuntu and get me a little bit bigger machine like this one. And put that in the CloudGenius VPC. Put that in the private subnet. Get me a private IP, not a public IP. So no public IP. CloudGenius, private, no public IP. Add some storage. Tag the instance. I'll call this my app server. And security group, I want to select. And I will select the working area security group because I want to allow all traffic from any location. Review and launch. And in this next instance, I will create, select this existing key pair and launch the instance. Now at this moment, we should be able to modify our configuration to include this private IP in our configuration. As you will see, in this example, we'll go to our config and in this place, we'll say paste. And instead of work server, we'll call it app server, the new name. Anything else is, everything else is same. So I'm going to save it and then SSH app server. And wait for the machine to initialize and all that. But that's the core idea. So I want to make sure that you are clear, first of all. So we'll go deeper into analysis of security groups and permissions and all that. But for right now, from the skeleton perspective, make sure that you are clear with this framework that we are setting together in terms of constructing a VPC. That I think that portion should be clear, which is VPC. We are giving it a subnet space, address space of 16. Meaning we can have about 64,000 machines inside this virtual private cloud. In there, we are just beginning to create two subnets, BC, private. And in this subnet, we will have about 256 machines. In this subnet, we have 256 machines. We are giving them an address space of 10.0.0/24, 10.0.1.0/24. So in this, we'll have up to 256 here. In totality, in the VPC, we can have 64,000. We created a work machine here, a jump box here, a router here, a gateway here, connected like this, and connected like this. And that's the connection. We are able to connect from our laptop, sitting here, go through the jump box into all the way in a tunnel method. I think that portion, I want to make sure that you are clear, and I will further elaborate the complexity involved in clarifying and understanding the aspect of security group, which is what we are working through right now, the issue that we are running into. we will deal with that. But before we get into that complexity, which we will, I want to make sure that you get this point crystal clear. And yes, we will go further complicated into great level of depth, but at least this portion, I want you to really comprehend very, very clearly so that you can.
So from work server, from app server or work server, you are using the router to the gateway to the outside world.
Correct.
Right.
I was attempting the update and it was failing.
Yeah.
Yeah. So
correct. But for
on the update part later. So hold on. I want to focus on the update part later. I want to focus on the security groups and the traffic flowing discussion later. Before we get to that, I want to clearly make sure that all of you understand the design of the structure that we are putting together from a networking standpoint, from a virtual private cloud standpoint, from a connection standpoint. Then we will go into security groups and flow of traffic, applications, mapping other things that we need, inserting a load balancer, inserting HA proxy, or creating a scenario where we can actually deploy a fully functional application and put customers and basically do the whole thing. We want to build it step by step. And I think this security group and the complexity of update traffic flow, I don't want that to muddy this other idea that we just finished discussing. So yes, we will go through security group complexity and updates and all that. But before we jump to that topic, please nail it and tell me that you got it, that you can actually implement something like this on your own with the clarity that we now have. In that, I want you to be super comfortable in understanding this section of VPC, especially when it comes to subnets and route tables and gateways. So gateway, route table, the association between routes to the gateway, with the private route to the NAC device, like that. To make sure that these aspects are clear to you before jumping into security group discussions. Right? Are you there with me? So Salam says, yes, that's good. What about other people?
Yes.
yes.
Good. Is this useful, what we just did? Is that useful to understand? Most cloud companies will just give this to you with a one button, but they don't tell you what's going on under the covers unless you do it like item by item, build things for yourself. Most companies will say, okay, click here to create a VPC and click here to launch your application and go be happy. But it hides so much things underneath that you don't really understand what just happened. And then you are essentially what I call locked up.
What's that?
You are essentially logged up, L-O-C-K.
Logged up, I see.
With the company. I don't want you to lock up with a company because that is called vendor lock-in. You don't want to get logged in. You want to really know what they're doing so that you have the choice to go away from Amazon, to go away from Google, to go away from Microsoft if you want to. Not that you have to, but if you want to, you could go away and say, bye-bye, Amazon, I don't want you. And that is possible only if you clearly understand what you are getting when you go to a cloud. Because you're essentially cutting down vendor lock-in. When you lock yourself in with a company, they hold you hostage. And you don't want that. You don't want to get locked up. And that is why I go into level of depth that I'm illustrating, because I want you to replicate this kind of a construct by buying a router, buying cables and Ethernet switches and laptops and machines and servers and physically connect them You could do the same thing in a physical scenario. You could do the same thing in any cloud setup, as long as you understand what's going on. Absolutely. Okay, good. So having done this, let me now proceed to the other idea, which we ran into an issue where the security group scenario is not essentially allowing us to have the traffic flow properly. And I want to diagnose that. Before we do that, I want to redo this whole thing in 5 minutes, like completely whole thing end to end. And now is a good time to just watch me, because what I intend to do is repeat whatever I discussed in the last 2.5 hours in the next 5 to 7 minutes. And let us do that. So here we go. Click. I will create a completely separate VPC. Create. We'll call it Badal. And the same CIDR. So it's not the Cloud Genius VPC, but a Badal VPC, different. Create. In this VPC, I'm going to narrow it down. I need to have subnets. I don't have any, so I'll create them. I'll call it the BC subnet 10.0.0.0/24. And one more subnet. Create. I'll call it the private subnet 10.0.1.0/24. Create.
Nilesh, questions here.
Yes, yes.
You leave the zones is no preference. So what's going to happen? Why this instance going to run them? How do we know?
So the zone preference, you could select A, B, and C. For example, if you are in Oregon, they give you A, B, and C, 3 choices. If you are in Virginia, they give you 5 choices.
Mm-hmm. No, my question was, you're not selecting any preference. So what's happening? Like, why my instance going to be running them?
So they will randomly assign you one of these guys.
Oh, randomly assign. Okay.
So you have no preference where you get assigned. So they'll just randomly give you one of these.
Is this important to know where my instance is going to be running?
It is. But I'm not currently actively selecting them because I don't really care for right now.
Okay.
In the next iteration of this that we will do one more time, we will include higher availability.
What they say?
Okay.
So in higher availability, you want to make sure that you are at least doing 2 subnets, one in every HA zone. So you want to have, say, out of the A, B, and C that I see, you want to select,
exactly.
Go ahead. Question?
No, I understood. Yeah, for higher availability, we have to select 2 zones.
So you want to have BCA and BCC. You want to have a private A and a private C. So you will have 4 subnets like this.
Right.
And they will be redundant. So that's how you will expand the complexity of the design, but not today, not today. So I want to make sure that you are with me on the core concept. I don't want to unnecessarily complicate things. I want to keep it really focused. And that is what I'm doing right now is this Badal VPC. We created 2 subnets. Now we'll jump to the routing table. We'll ignore this one. And then create a route table. We'll call this the BC route table and create. We'll also have one more route table, create, and we'll call this the private route table and create. Now, after having created the route tables, I want to also have a gateway. So I will create a gateway. I will call this my gateway and create. When the gateway gets created, it doesn't seem to show me, and that is a bug. So I want to refresh my browser, and then I see it that the gateway got created. I want to attach it to the Badal VPC and say, yes, please attach. So when I do that, the gateway that I just created gets attached to the Badal VPC, which is nice. So now I have two subnets in the Badal VPC and two route tables for the Badal VPC that I created, and I'm going to ignore this one that I do not want to use. So on the BC subnet, I want to make sure that the routes are anywhere in the VPC, edit, and I'll add another route to the gateway and let it go anywhere on the internet using the gateway. That's great. So I'll save. Now on the BC subnet, I want to associate this subnet with the BC, the BC route table, associate with the BC subnet like this here and save. So that's one thing. Next thing, in private, like here, I want to go to the route section. I want to expand the route, and I want to have another route which needs to go to anywhere on the internet. But then I don't have a router in this VPC because I need to buy one. Every VPC needs a separate router. I don't have one here, so I cannot add it quite right now. So I'll go cancel. On the subnet association, I can edit and make sure that I select for the private route table, I select the private subnet and save. Now I need to go back and get a router. And that I can associate with my route table here. So back to my EC2 section, I will launch an instance and I will go grab a AMZN NAT 2016, and that is the NAT I get. So this is the NAT I want. I will select that, and I will select a little bit bigger machine, like M3 medium is a good one. Where is that? M3 medium, there. And then I configure the instance. I'll put that in the Badal VPC, put that in the BC subnet, get an IP address. So Badal, BC, enable, go forward, SSD, go forward. I will call this my router. And in that router, I will add some security group. I will like to simplify the security groups. So I will create a new security group. I will call this my, let's call it router. And this router security group will allow traffic, primarily all traffic, as long as it is coming from my other security group, which is what I want to add. But for right now, I don't have an entry, so I'll just create a dummy entry like this. Anywhere from the VPC, please allow traffic. I'll add one more rule, which is allow SSH from my location. So the idea is for my router, I want to allow all traffic coming from, as long as it is coming from the VPC. And SSH, I want to allow it as long as it is coming from my office, this location. And then I will proceed, review, and launch. And then I will launch and select my key pair, acknowledge, proceed. Now that gives me a router. This is the router. I will go create one more box in EC2 and say launch an instance. This time I'm going to launch an Ubuntu instance and put that in M3 medium here and configure instance details. I want to put the Badal VPC, put in the private subnet. Don't want to get an IP address, disable. So Badal private, disable IP, disable public IP, add some storage, tag the instance, call it my app server, or call it Badal server. And security groups. Now here I want to create a security group for myself, for my app servers. and be lenient with the rules. So I want to allow all traffic as long as it is coming from anywhere within the VPC, and also allow SSH traffic if it is coming from my location. So basically opening up all traffic as long as it is within the VPC, and that's my app servers security group, and reviewing and launch. When I launch, I will select my ID, my key, and acknowledge, launch the instance. Now I have 2 instances in the Badal VPC. If I sort by my instance list, instance count, and look at all the machines that are M3 medium size, so I have a Badal server that I created and a router that I created, a capital R router. And these 2 machines are the ones that are in the Badal VPC. So I want to grab the details for those guys. So the router is here, and that is what I will take to my configuration here and call this. And by the way, you will notice that I'm using the router as a jump box, which is okay, but it is not recommended procedure, but it will work. I will also use the Badal server IP address, which does not have a public IP. I'll take that IP address from here, copy, bring it over here, put that in the app server name, save it, and call it my Badal server. And that's the name I want to use. Now I will save, come back here in the in the terminal, and clear up, make some room, and then SSH to. By the way, before I proceed, I need to remove the own host file, which I can just go back here and empty them. So delete and save. That should work. Now back here, I will SSH to my jump box, which is going to actually connect to the new router, the capital router I have. So I should maybe rename this if I want to. So I should rename the jump box to the capital router. As you will see that I renamed it 2 places, one here and one here. So that is my router as the capital router name. Names are irrelevant actually. And I'm going to connect to it, and it lets me connect. I connect it to my router, which is nice. Now I will want to connect to this box. So I will connect to that box like this, and it lets me connect to the machine inside in one shot. And now I am connecting to the machine 10.0.145, which is the Ubuntu box inside the Badal VPC in the private subnet. And here I should be running apt-get update, and it is still failing. Interesting. So I will understand what's going on. I don't want to keep you held up in this diagnosis as to why it is failing, but apparently it is failing the exact same way. Something else is happening that I don't know exactly what's causing it, but there is a failure happening, which means I will come back to this issue. We have tried it in 2 different VPCs, similar setups, not exactly identical setups, but similar setups, similar policies, similar security group scenario, similar routing tables. But still the traffic doesn't seem to flow. We are able to connect, no problem, but our flow in the other new VPC that I created called Badal, we have a very similar design. We have a BC subnet and a private subnet. In there we have a router here and a app server called Badal server here. And this security group allows anywhere to connect from within the VPC. So we are going to go outside like this. That traffic is not working. We are sitting here on our workstation, and we are able to connect through the SSH like this. And that SSH connection with a jump bastion tunnel seems to work just fine. We are able to connect here, no problem. Other people, bad guys, they cannot connect because they will get rejected because first of all, they don't have a private key and they cannot even route traffic here. So there is no traffic route for them. The open issue that I am still running into is why does the traffic not flow from here to ubuntu.com? That is what I want to understand. it may be the case that something is wrong with Ubuntu. So I want to ignore that piece and maybe directly ping yahoo.com to see from here it pings Yahoo, and it doesn't seem to. That is, so this is something that I want to understand, and I will get back to you on this maybe tomorrow or maybe some other day as soon as I find it. But we will get to the root of what may be happening. Having done this, I would like to ask you to reproduce the same setup in your accounts to make sure that you really understand the nitty-gritty of helping and clearly understanding and articulating what is a data center that you want to construct in your own cloud. By the way, one quick example that I want to illustrate before I stop talking about this topic and guide you to go to here in this module, module number 11. And I would like you to cover these things all the way from 11, unit number 1 through 16. And you please review these things on your own. But for right now, I will illustrate one quick point. The point being, in our VPC, if you go to one of our VPCs like the Badal or the Cloud Genius VPC, for example. So in the Cloud Genius VPC, I'm going to filter it down. And here you see that the route table has a private route to anywhere on the internet using the router device that you already know of. However, what you will now see is this thing. I will go to Amazon EC2 console again. Look at my router in the Cloud Genius. This one. This is the Cloud Genius router. And this is the Badal router, by the way. And this is the Cloud Genius router, as you remember. And what I intend to do is I want to kill this box. So literally I will kill the router. And so when I kill the router in Cloud Genius VPC and I terminate, you will see a funny thing here. In the Cloud Genius VPC, when you do not have a route in the routing table for the private route, you don't have this device anymore. You just killed your router. I just killed it right here. Right? The router is getting shutting down and it will die in a moment. So when the router dies, it's going to cause a crazy scenario, which is called a black hole. That's what you will see momentarily. So when I refresh the screen, you will find that in the Cloud Genius VPC, in the private route table, the routes indicate the route to anywhere on the internet is a black hole. This black hole shows up because on the other screen, I killed the router, killed it. And that is why you see a black hole. And now you have seen that the router has terminated. So it is dead. You will see the black hole another time in a different VPC, which is the Badal VPC. You will see the same thing here, the private routes. Hold on. I think I forgot to include the expanded route table for our private route for the Badal VPC. That may be the issue. So let's go 0000/0 and router, Badal router. That's what I want. And so now we are going to save it. And now we have a route that goes through this instance ID 44A06. Let us compare that. Is it this router 44A06? Yes, it is. Which means we had that entry missing, right? I did not see it correctly. I now notice that the Badal VPC private subnet did not have a route to the internet through the router, which I just added. And I'm hoping that this should be the resolution to the update problem. No, it is not. Something else is happening. And so we'll get back to that. I was just hoping that that is the case, but something was fishy. I don't know. I'll go review the recording and check whether I actually added this before already or not in the Badal VPC. I think I added, but then it disappeared. And it happens occasionally. Things go wrong. So it should not happen, but it did. So checking again one more time, private route, it is there and it is active, which means this should work, but it is not. Okay, fine. So I'll do the tracing of this later. I want to make sure that I change topic and not spend your time in root causing the trouble that I'm running into. Having said this, let us recap what we covered, and I want to give you some work to do. The work that I would like you to do is focused on understanding VPC primarily. And essentially what we are doing is building a data center for ourselves in the cloud. In that design that we want to put, I would like you to have a carved out area in a VPC of your chosen size. And these are the numbers that they recommend in Amazon, but this is not a requirement. You can make a VPC as big or as small as the RFC 1918 suggests. They have the entire address space carved out for private address space. As long as you are fitting in the private address space, you can have a VPC as large as it will let you. So that is the limitation of size of the VPC. In Amazon, the size is 65535. That many machines you can have in one VPC. That's the current limitation of Amazon's implementation. In other examples, you could have a bigger VPC. You're creating a data center. And my goal for you is to illustrate to me and show me that you have created a VPC setup, handmade, custom made, with at least 2 subnets and a gateway and a router device, a jump box, a work server of some sorts, and the associated connection of a jump that you would like to do from here all the way through here. And I will root cause the traffic problem that we are running into. So I will resolve that in a separate message I will send in Slack chat. But apart from that, this step that I just did for you, I would like you to do it yourself. And to assist you in doing that, this setup of module 11 is going to be extremely helpful. It basically walks you through step by step. There are 16 short little videos. Now, this is me, by the way. If you have, by the way, you haven't seen me, so I will show you my video, my face at some point. I think you may have, but I'm not sure. So will you be
showing a video with your dancing?
I know there is one on YouTube. I'm just kidding. Yeah. So what I'm suggesting is go to this link, and in that link you will find step by step, very, very narrowly focused ideas on doing what I just described to you in this long discussion. I would like you to actually do this exercise. And if you tell me that you find that this is boring, please don't do it. But please tell me that you find it boring, and I will find something interesting for you. As simple as that. The idea is to learn and not get bored. If you get bored, this program is bad. I should stop doing it. If you are finding it interesting, please do it. And that is how I.
No, this is fun. This is good.
Good.
No, this is good. Good learning.
So yeah, go deeper.
Good learning.
The more you do it yourself, and the more questions you ask in Slack chat, I find it interesting. I find that I'm happy that you are actually doing it. And that is the real reason I do it, is because I want people to learn. The reason I run this bootcamp and all that is primarily because I like teaching and that I want people to learn these things so that you get to develop your understanding of nitty-gritty in detail so that next time you don't have to go deeper because you already know. And that's the core idea. So with that, please do this. Module number 11, 16 short 1 or 2 minute long videos, not more than that. That should take you 1 hour, literally. If you're doing it diligently, it should not take more than 1 hour because you've already seen it. You also have a video recording from today that is coming up pretty soon. So I will post that in the same download method. It will pop up in your screen, in your computer. And on the side, I will diagnose the issue that I ran into separately, and I will update you on Slack chat. Any questions up until now as to what I expect you to do? Any questions? So my expectation essentially is what I just said. Do what I just did. That's my expectation. And show me that you did. That will be even better. So show me that you did. Show me what issues you're running into. And in more importantly, I want to see the clarity in your understanding. So the answer no was to what? I did not get Salam. So please explain. You said no, Salam, but I did not understand what no.
No, Nilesh, I say I don't have no questions. That's why.
No questions. Okay, good to know.
Well,
Go ahead.
on the machine, is that a M2, M3? What size of machine do you think?
So technically, the cheapest should work. The cheapest machine you can get is a T2 Micro.
T2 Micro, yeah.
This T2 Micro works.
Okay.
It is cheap, it is free, and it should work. It is free tier eligible, so it should not cost you money. It works.
And Nilesh, if I keep the keys or router or any other instances up and running, do I get any bill?
You get a bill when you have a machine running. So these machines that are running right now, a bill 1, 2, 3, 4. To create a VPC, there is no charge.
Okay, but
no charge.
Keep it is going to charge.
No. VPC $0. Subnet 0. Route table 0. Internet gateway 0. DHCP option set 0. Elastic IP, there is a charge. They will charge you.
Elastic IP, okay.
They will charge you.
Elastic.
There is a charge. Peering connection, charges. Security group, no charge. Network ACL, no charge. Customer gateway, charge. VPN, charge. Virtual private gateway, charge. So you want to remember what is free, what is not, by reading the terms and conditions of the cloud provider. I just told you quickly what is free, what is not.
Can you go over that again, please?
Okay, I will do that.
See? It's very interesting because, I was practicing, then I get a bill,
I know. So okay, VPC, free. Subnet, free. Route table, free. Internet gateway, free. DHCP option set, free.
Elastic IP bill.
Yeah. Everything below, think of it as it is a charge. However, network ACLs and security groups are also free. These two are free. So below this Elastic and below, think of it as they are going to charge you. Elastic charge, endpoint charge, NAT gateway charge, peering connection charge, VPN everything charge, security group free. Network ACLs free. Okay, these two are free. Everything below this is also going to be a charge. Elastic IP charge, everything charge except these two. Okay, simple. Yeah. So one more thing, when you are dealing with the machines, they will charge you. They will charge you for every instance you launch. Every instance, including T2 Micro. unless the total amount of time that you launch an instance of T2 micro size in totality is less than 750 hours every month. So if you run 4 instances for 1 week, it is free. Okay.
Yeah, which we don't need it at this time, so we are not running a website.
You're not incurring a cost. And by the way, the pricing of T2 micro is so dirt cheap, your bill is going to be like 5 cents. So don't worry. Don't worry.
Sometimes if you tell them, hey, I was practicing, I am a student, so sometimes they take it off.
Oh, they will take it off. Absolutely. Absolutely take it off. They're very nice about it. They're very nice about it. And I don't use this cloud at all. So my bill, you can see, is very low. So my usage for Amazon is as low as your usage. So let us see my bill. Here we go. What is my bill? $0. Or the actual charge is like 42 cents. So view my products. And bill is 42 cents. So it's very, very cheap. And even there is a coupon for that. So I don't use this cloud much. And so you can see my current cost is whatever I'm running, but the overall bill will be a couple of cents. Because I kill the machines as soon as I'm done. So I go back here and I kill, like here. And I will actively kill everything that I have. 4 machines, kill like this and say, terminate please, and go bye-bye. And so the machines are dead. My bill is suddenly dropped to 0. That is what I think you should do. And what I just did is I killed everything. And I will kill the whole VPC again all over and then build it up again all the way one more time to root cause the problem that I'm running into. And in the context of cloud, it is easier and cheaper to just kill the whole thing and move on, because it's all rental, right? We just rent them. We don't own them. If you buy a computer from HP or Dell, then it becomes your puppy, right? So this discussion about, you may have heard of it before, is this discussion is about a puppy versus cattle, right? So imagine if you are in Texas and you see a cowboy on a horse with whiskey in one hand and a gun in the other hand. And this cowboy is managing 10,000 cows. Now one cow gets sick. What do you think this cowboy will do to the sick cow?
He's going to shoot him.
Exactly. That's what I'm saying. Right? In the cloud, you have tens of thousands of servers. If a machine goes bad, if something goes bad, just shoot it and move on. They are cattle. Now imagine the other case. You have a puppy, a family of 3, mom, dad, and a kid. Right? And the puppy goes sick. What do you think they will do?
No, this is your kids.
Exactly.
You have to treat them.
So you go to the doctor, the veterinary, and everything and all that. So you basically take care of the puppy. And so a puppy is like a computer in your data center. The computer goes bad, you go fix it. You buy a hard disk, you buy a computer, you buy cooling, you buy power supply, you buy this, you buy that. You deal with the puppy. But that is not the case in cloud. It is cattle. You have the cloud and you have basically virtually limitless instances. Or you can call them droplets. You can call them whatever you want, but they're basically cows. You find that something goes wrong, you just shoot the whole thing and move on, man. New cloud. That's the difference between cloud and data center. Puppy and cattle. So the discussion you will find pets versus cattle. Pets versus cattle discussion. You will have it many, many times in many places. You will see this discussion happening. Something goes wrong, shoot the cow. Something goes wrong here, take care of the pet. And that is a problem in data centers. You have to actually take care of the machines. And that's a waste of money, waste of time. And you don't want to waste money and time. Instead, you go the cloud route and you kill if something goes wrong. The reason you can kill is because whatever we are doing right now here and all that by hand, by clicking your mouse and typing things by hand on a keyboard, all of that is boring. I just said that. I did that twice, but I have a reason to do that twice. If you do it over and over and over, it gets really, really boring, right? And that is why we should deal with our cloud infrastructure as if, excuse me, we should deal with our cloud infrastructure as if this thing is code. And that is what we will cover in the second segment. We are basically managing our cloud infrastructure in form of code.
Code.
Yes. So we will script, we will write, Chef and Ansible tooling and Docker and this and that. So a bunch of other things. The idea is to not do these things by hand, by mouse or by keyboard. That gets boring. Instead, write a little bit of code, not too much. So not going to scare you with coding, but that is exactly what we will do, is to deal with infrastructure as code.
As cloud formation?
That is one example. So cloud formation you just mentioned is a Amazon specific way of doing things. Which is okay, but not okay in my books. Because if you do it with Amazon specific things, you are stuck with Amazon. You're stuck with Amazon. Now, if you do something in cloud formation, then you can do only on Amazon Web Services, and then you are stuck.
Okay.
That is bad. Don't do it. So what do you do now? So we use Terraform, which is open source. And we'll do it in an exercise, by the way. This whole thing I just did today, you will do it in Terraform at some point. And Terraform is an open source product. And you will find that here it is. You can see the GitHub code, and it's included in the workstation you have and lots of things. But the idea is, if you do it in Terraform, you can get it to work in any cloud.
Oh, okay.
So we are providers of AWS, Azure, Chef, CenturyLink Cloud, CloudStack, blah, 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 goes on, DigitalOcean, Heroku, Cloud. So the whole bunch of things you can do. It is agnostic. Whereas if you use this tool, there is absolutely nothing wrong with that tool. It works. I'm not complaining about it. All I'm saying is that if you use that tool, you're married to Amazon Web Services. Married. Your marriage. Are you interested in getting married with Amazon? I don't think so. Right? I don't think. So that is not what you want to do. You want to remain neutral. And that neutrality is what I like. Because this remaining neutral to a cloud gives you the flexibility to go away. You don't have to go away, but you can.
Exactly.
That is important. So I prefer open source alternatives. because they give you neutrality and flexibility when you're doing business. Otherwise, you're getting married to Amazon or getting married to some cloud provider, which is a bad idea to begin with, right?
Mm-hmm.
If you get married with Amazon, then you are basically, you cannot get away from them and you have to pay them whatever they want.
Exactly.
You have no way to get out. And that is bad. And that is why neutrality and open source and neutral solutions that are basically your own property. Open source is your property, by the way. This open source example that I'm just suggesting here, Terraform, is open source. It is your property. It is my property. It is community property. You can make edits to it like I can. You cannot modify CloudFront or CloudFormation. You cannot change it. It's Amazon.
Mm-hmm.
It's right there. And here, CloudFormation. And it works. Nothing wrong. But then it is only Amazon, nowhere else. And you don't want that. You want to study this, by the way. You want to know what they're doing. And yes, we will do it. But I am not going to recommend this as a tool. I'm going to say, go Terraform.
Okay.
We will use CloudFormation. Don't get me wrong. But I will say, use this. Why? It is yours. Open source.
Mm-hmm.
Right? So now let me summarize. Please do this. Show me that you did. Connect with me on Slack and let us figure out if you run into issue. In the meanwhile, I'll spend some time and understand what may be causing the traffic issue that I ran into today. With that, I will stop recording.
All right. Have a good night, everybody.
Sure.